In our third example, we're being asked to integrate the cosine to the fourth of x, which looks a little different than the previous examples that we've seen, obviously, in that only cosine is present. And since it is raised to an even exponent, really about the only recourse that we have is to go ahead and utilize the identities that we had talked about throughout this section, namely the cosine squared of x identity. That's a manipulation of the the double angle identity for cosine. So the formula here that I'm sort of writing off to the right side just has to be committed to memory. You're going to use it quite a bit throughout section 8.3. So cosine squared of x is 1 plus the cosine of 2x all divided by 2. Now, the way that we're going to have to introduce that particular formula into this problem is to rewrite the cosine to the fourth as the cosine squared, which rather than wasting a step in writing that, I'm going to go ahead and make this direct substitution, 1 plus cosine of 2x over 2. And since that only takes care of cosine to the second power, if I raise all of this to the second power, in essence, I now have something that is equivalent to the cosine to the fourth. Now, the next step, it's not necessarily an enjoyable step in that you will have to expand this entire rational function out. And the top is going to require a little bit of foiling here. And, there really is no other way around it, and you just have to anticipate those types of things and that algebraic rigor being associated with these kinds of problems. So if we go ahead and square the bottom first, that'll be pretty simple, 4. In squaring the numerator, 1 times 1, of course, would be 1, and then if we have the cosine of 2x times 1 two different times, then of course we would have 2 cosine of 2x. And then for our final term, cosine of 2x times itself, we would have, of course, the cosine squared of 2x, all with respect to x here. Now, at this point, you'll notice that the cosine squared of 2x in and of itself is not quite possible to integrate, not unless we manipulate it by using another cosine squared of x formula, up here again. And so that's what we're going to do next. But prior to setting that up, let's go ahead and break this apart into some separate integrals so that we can manage it a little bit better. So one thing I might suggest is perhaps we could take a 1/4 out in front, and essentially now we would be integrating 1 with respect to x, quite easy, plus, and then we would integrate 2 cosine of 2x with respect to x. And then for this final piece, the cosine squared of 2x, what we're going to have to do is one more time rely on this formula up here in the right corner, but we're going to have to be a little bit clever about it, because we'll notice in the formula our variable is simply x. Well, that's something that shouldn't bother you here. Obviously, we're dealing with a 2x in our particular cosine squared function in this integrand. So wherever you would place an x in the original formula, you would just be placing a 2x at this point. So rather than the 1 plus cosine of 2x, we would have 1 plus cosine of 4x. It's handled very simply like that. Now at this stage, we can quite easily integrate these first two integrals. And this third one here is going to be pretty simple at this point. Perhaps it might benefit us from doing a rewrite of it. And this is a step that obviously when you guys are performing your homework or working on a test or a quiz, you might be able to eliminate and consolidate this with the following, the step that's to follow. I'll leave that entirely up to you. But for the purpose of this little video, I'm going to go ahead and split this apart. We'll call this, let's just break it apart like this rather than bring anything out in front. Integration of 1/2 with respect to x plus the integration of 1/2 cosine of 4x with respect to x. Okay, and here we go. Integrating 1, we of course get x. Integrating 2 cosine of 2x, now we got to be careful. We're kind of thinking that there is a u substitution of 2x, of course, and that derivative would be 2 dx. So we're going to have to offset with a 1/2. However, this 2 that's already here is going to sort of cancel out that 1/2 that we were to bring out in the front, and essentially all we're doing here is just integrating the cosine of u, which of course would be positive sine of u. And the u that we're talking about is 2x here. Our next third integrand here, integration of 1/2, very simple, 1/2 x. You'll notice that that can combine with this x here in the front, and we'll do that in a moment. And then finally, integration that we have here at the end, another u substitution where we could let u be 4x, the derivative of course being 4 dx. We would offset with a 1/4 that would also be joined by that 1/2 coefficient that's already in front of the cosine to give us a 1/8 coefficient. And then the integral of the cosine of u, of course, is the sine of u. In this case, our u is 4x. And essentially this answer that we have is correct. There's really nothing wrong with it. You'll notice that a back of the book or perhaps a multiple choice response will most likely combine some like terms. So the x and the 1/2 x would combine for 3/2 x. Really won't do much of anything with the sine of 2x or with the 1/8 sine of 4x. And I don't really see much of a need to distribute the 1/4 x in, or I'm sorry, the 1/4 in. Of course you could. There are other ways that this could be manipulated by getting a common denominator all among the values that are in the brackets, and then factoring out a common factor there. I would like to just show you what that would look like, just to prepare yourself in the event that that were to happen. Essentially what's going to happen, I'm going to switch colors to sort of illustrate this a little bit better. What would happen here, get my color palette here to work, is this 3/2 would essentially become would require a denominator of 8, which would force us to rewrite it as 12/8. And this sine of 2x would essentially have a numerator of 8 and a denominator of 8, and we would not have to touch this sine of 4x since it has our denominator of 8. Now with that in mind, you can go ahead and see that 8 denominator seems to be consistent among the 3 terms in the brackets, so we could factor out a 1/8, which would give us a 1/32 in front. Don't forget we already had a 1/4, and at that stage we could then go ahead and rewrite what's left. It would be a 12x plus an 8 sine of 2x plus, and then this 1/8 already factored out, so all we would have left is the sine of 4x plus c, and that would be a suitable answer as well.